Okay, hello everybody. My name is Arūnas Urbšys. I'm responsible for sales and marketing at SolidWorks company. And today with me here is Liudas Liepa, our application engineer, who will take over later on the session for a live demo of BuiltWorks. I would like even to extend a little bit today's session title by saying expanding the power of SolidWorks for next generation structural design. Well, I would like firstly to introduce ourselves a little bit, who we are. SolidWorks is a software development company, SolidWorks solution partner. Established in 2008. The company is registered in Vilnius, Lithuania, so we are just 2 hours away from you. And the company was created by a team of structural steelwork software professionals. I mean, we are less developers than the structural engineers in our team. So I'd make bold to call all of you our colleagues, because we also do have mechanical engineers in our companies, structural engineers. So we are pretty much engineering company. And behind the SolidWorks company, there is a longer history of local Lithuanian company, INRE, which acts in Lithuanian market in structural building plan design areas. So in November 9, 2009, we released first commercial version of BuiltWorks software, BuiltWorks add-in application. So it was quite a rapid development. In 1 year we launched a brand new product because of that experience we had behind the company established. What is BuiltWorks? It is add-in application for SolidWorks environment, which provides tools for parametric modeling, links for analysis and design, some tools for connection detailing and automated generation of drawings and creating of specifications tables, bills of materials, specifically for structural steel design to meet architectural, engineering and construction, as well as plant, process and power industries requirements for flexible modeling tool that include extended integration capabilities. BuiltWorks is interface for structural design for SolidWorks, and it is the interoperability functionality for SolidWorks to bring SolidWorks into architectural plant building design workflow. We expand the native capabilities of SolidWorks, not replacing the power proven 3D modeling engine of SolidWorks. We're just moving it to next level by extending the list of existing tools. Why we add additional structural modeling objects into SolidWorks? Here is a comparison of SolidWorks structural member, or as it's called, weldment, and a new object that we bring with BuiltWorks. It's BW beam object, or BuiltWorks member. You can see the main conceptual difference. The BuiltWorks member is a single feature, single new feature in SolidWorks feature tree, comparing to structural member, which is combined from several features I can say at least 4 features are needed to be created in the tree to create a SolidWorks structural member. And this, of course, impacts the performance, the capabilities of SolidWorks. Moreover, as you all know, with weldments you can only work in part modes, then manually assembling them into assembly, while with BuiltWorks you can start working in assembly mode, or you can work in parts or in combined way. So it's more flexibility and more power, more performance in SolidWorks. Now the second aspect of BuiltWorks is the range of interoperability features. It is the support of most popular in this specific industry area data exchange formats CS2 and SDNF, still detailing neutral file, and CS2 stands for Thin Steel Integration Standards Revision 2, which are the main structural steel data exchange standards. With those, with support of those standards, we provide the SolidWorks link to plan design, enabling to change data with such plan design systems like Aviva, SmartPlan 3D or PDS, AutoPlant, and other plan design systems. We also do provide the bidirectional link, direct link to StatPro, the most popular structural analysis and design system. So we enable SolidWorks user to do the structural analysis, code-based, code-checking-based structural analysis for the models in SolidWorks. But with CS2 format analysis model, which is supported in BuiltWorks, we can also link SolidWorks models to other structural analysis systems like SAP 2000 or RISA or Drupal Aerostype, and a range of other who supports CS2. Same formats also provide link to detailing and fabrication systems like Tekla or StruCAD or another. Well, Tekla and StruCAD today in one team, but then there is SDS2 high-end fabrication system, and also to wide range of other building and structural design systems like Autodesk, Revit, Bentley Structural, ProSteel, Gratec, Advanced Steel, AutoCAD Structural Detailing, and so forth and so forth. So the main concept and philosophy of BuiltWorks is to enable SolidWorks user to prepare general arrangement models of building and plan structures using typical AEC structural design rules and features of steel materials, which we bring with a range of steel section profile databases that are provided with BuiltWorks. Also to enable SolidWorks user to effectively exchange the intelligent structural steel design data with third-party AEC and plan design and detailing systems by putting SolidWorks inside the whole plant or building design workflow. And of course, enabling to make structural analysis and design of created structures using either SolidWorks simulation or leading market analysis and design software applications. So with this proposed, BuiltWorks serves you as SolidWorks users, allowing the equipment modeling, for instance, the natural proposal of SolidWorks or pipe routing or another SolidWorks functions, to be based on realistic building structures whenever it's required. just to emphasize the importance of those interoperability standards, here's a typical mix of solutions in engineering and procurement and construction companies. I don't say that each company have this variety of plan design systems and structural design systems and analysis systems, but if you look from company to company, there are a mix of various solutions, and typically there are several departments in such companies: the mechanical department, structural department, plan department, and so on. So for equipment design like SolidWorks, of course, there are also some other vendors, but we don't talk about them today. What we wanted to stress the interoperability requirements to enable all those applications to work together. So if we take a closer look at what standards, data exchange standards, those applications do support, we always and everywhere need either SDNF, the older format for still data exchange, or the current trend format CS2. For piping analysis, there are another formats. Now, what we have today in SolidWorks is just IFC for transferring this type of data between the applications. Why IFC is not exactly good for that? There will be now the illustration which nicely shows the main difference between IFC and CS2 formats, showing that IFC is used for horizontally integrate different disciplines, while CS2 format was specifically developed for structural steel industry and used to vertically integrate the design, analysis, detailing, and fabrication processes. So here is that illustration. So having IFC inside SolidWorks today, we with BuiltWorks bring additional format which very much extends the interoperability capabilities of SolidWorks using IFC. So a CS2. So we remove from this workflow IFC and extend SolidWorks by adding SDNF and CS2 format, and thus making the SolidWorks sort of data-centric solution. How can it be used in this way? We are going to illustrate today, and just briefly mentioning the wide range of various applications which they do support CS2, and BuiltWorks, or we can say SolidWorks, is supporting CS2 today as well. So this is what we would like to illustrate. One demo should explain how SolidWorks became a data-centric solution by integrating SolidWorks into structural workflow. So we can import the general arrangement model from, let's say, plan design systems, which are not designed, not developed to have the deep detailing and modeling capabilities. The plan design system needs just a very basic structure for planning the plant, all plant infrastructure. Now, we can import this data into SolidWorks and perform the parametric modeling of a steel structure using BuiltWorks tools, as well as we will show later on, also the native SolidWorks functionality. SolidWorks structural members can be used here as well. We can also link this model to structural analysis and design system, and update the model based on analysis results, automatically update the model. We can then continue modeling the structure by detailing the connections and then issue the drawings and specifications, or we can transfer further the model for a high-end structural design and manufacturing systems such as Tekla or Advanced Steel or Pro Steel, as mentioned. And then again, we can use either same CS2 or SDNF format depending which serves best. So just to make the whole overview, Liudas will try to show this workflow in live. For the end, depending how much time we will have, we also would like to demonstrate how BuiltWorks allows to use the pure SolidWorks features, pure elements, extrudes and other features which are also now possible to export to CS2 and then use in another applications for interoperability and further detailing purposes. Okay, at this point I would like to finish with a PowerPoint presentation.
Okay, thank you Charlie and Arūnas. Okay, and let's continue with the live demo. First of all, here I have some STP file which is exported from Intergraph SmartPlan 3D software. This is a CS2 format file, and we're going to import this file into SolidWorks. To start from, I need to decide where I need to import my structure, into part context or into an assembly context. It depends on the complexity of the structure. This structure is quite complex, so I'm going to create an assembly. Let's create a new folder and save the structure. First of all, when you launch the SolidWorks and locate the BuiltWorks toolbar, here are allocated all the features, all the tools of the BuiltWorks, and now I'm going to use the BuiltWorks import, and there are some import options. I can import the analysis model from STAD, some kind of geometry from SDNF, and also there is a possibility, as you will see later in this demo, we can update the results of design from STAD Pro. Now I'm going to import the CS2 file. Here opens the dialog, and first of all I need to locate that CS2. Next I can decide whenever to import offsets of the structure or not. Also there is a possibility to choose whenever to import only the sketch. The structure also can be imported as elements, as Arūnas mentioned. But since the detailing possibilities of SolidWorks are quite limited, we are going to import as members. This option stands for BuiltWorks members. Also, the model has no plates, and so this option is not necessary. Next, and the most important, is to select the correct map file for the profiles. Since we are going to import the structure from SmartPlan 3D, we need to select the particular map file. These map files can be prepared by users themselves, or there are several default files which can be used. Okay, and simply next going through the wizard. First of all, the source system offers me to choose from various different profiles. The main difference between these two are that here are the same profile, but the standards are different. The first one is European, and here is the German standard of the same profile. So the system allows user to choose the correct profile name. And here is the preview of the sketch of the structure. In the dialog, you can center or position the sketch anywhere in the graphic area. Next, the preview of the profiles is being generated.
While it's updating, I just wanted to comment one through the sentence. He said SolidWorks detailing capabilities are limited. He mean that if we use weldments and we use weldment connection treatment features, there are just two options to trim by angle or by straight line from member to member. That's it. Maybe Ludas will show later on briefly the wide range of connection detailing and trimming options based on structural engineering rules a little bit differently from mechanical engineering for machinery support design tools. So that was the meaning, but it doesn't mean that SolidWorks is not powerful enough to do whatever you want.
The preview is generated, and automatically the next dialog opens where user can exclude some of the unnecessary members from the structure. Next opens the dialog where user can join splitted members, because this CS2 came from SmartPlan 3D, but it was exported to some kind of analysis and design software. Just simply selecting the splitted segments, we're joining them. Okay. We have few columns joined. Next, the system collects all the members because the next dialog which will open will allow us to group all the members into several parts just simply by adding new groups and selecting the members from the graphic area. We are creating the groups. Now we are going to create one part for these 4 columns and a lot of parts for the rest of the members here. Okay, next, no more steps to go. We can click OK, and the structure is going to be imported. In the final stages that the system allows us to review the imported sections of the profiles. If everything is okay, we simply click OK. And as you can see, the sketch is being created firstly, and next the members are being placed along the sketch lines.
Ludas simply did not make many groups, but grouping has some meaning actually. Some same type of members can be grouped into separate parts, multi-body parts, which then can be processed in the groups. So in this case, for just savings the time, Ludas showed that he grouped only 4 members in one group, which will be created in one part file. the rest will be imported as individual parts, but of course in normal working mode you would continue grouping necessary members into logical groups until you are satisfied with a set of groups which will be created as separate parts. And of course you see that everything is being created in assembly. Even if during import Ludas would choose to create not BuiltWorks members but SolidWorks structural members or so-called weldments, that would be immediately all created in assembly as separate parts or in multi-body parts as you group them during the import. So after the model will be automatically created by import procedure, Ludas will show just a couple of things, what those structural members or BuiltWorks members are actually, from what they consist, and what modeling tools or placement tools you can use to enhance your structure, modify your structure, or create your structure from scratch. Well, it's almost done, but meanwhile, I just wanted to encourage you, if you have some questions about BuiltWorks or what's going on here, or if you will miss something what you wanted to see, please type your questions in the chat window so that the host of the webinar would be able to transfer later on to us. As well as I did show the broad range of various applications from structural industry, so I would like to hear from you what other structural application, either analysis or detailing or modeling, do you use in your daily work? So if you would just type your brand names in chat window.
I will probably continue. So here are the structure imported, and as you can see, those 4 columns which was good, they are imported, and in the single part. Now if I go to the feature of the BuiltWorks beam here, opens the dialog where I can change the orientation of the member by selecting those so-called cardinal points, or simply by...
Please, Ludas, show the databases of profiles that are included.
Okay, I will show that. So the database which BuiltWorks provide consists of various international databases based on the particular international codes. More about orientation, here also the offsets can be added, symmetrical or asymmetrical as well. Okay. Maybe next what I needed to show is that it is possible to place the BuiltWorks member without having a sketch line. This means that you can place the member from one point to another. And also the various possibilities of orientation. For the profile, user can use not only the BuiltWorks database, but also the custom library, which might consist of SolidWorks development profiles, which are downloadable. Okay, let's create this member here. And before further detailing, we are going to export this structure to analysis and design software. For analysis and design software, BuiltWorks offers a bidirectional link with Stat Pro application. Here, we can export objects such as elements. We can export only the sketch lines. Also, we are going to export BuiltWorks members, so the option for that is checked. We are going to export all geometries, and there are possibility to choose the unit system and the design code and other various options for design and optimization. After I click OK, the structure is being exported and the Stat Pro application should launch automatically.
By the way, while it's loading, there was a question from the audience: is it possible to import plates to Stat or only beam elements? Only beams are being transferred to Stat and back in this case.
Okay, so the structure is imported into Stat, and from here you can continue with analyzing, adding supports, applying loads. But I'm not going to do that. I will just change the profile of the few columns. Let's select these 4 columns here.
But you noted that while we were importing the structure, which was the analysis model, CS2 file analysis model, therefore it was split to finite elements. We joined those elements to single columns as it should be, and now when BuiltWorks exported the model to Stat Pro for analysis, it again split it automatically the members to finite elements as it should be for structural analysis purposes.
Okay, I changed the profile of these 4 columns here to the bigger one. Now, as usually needed to do is to save the results file separately from the original Stat Pro file. Now I can close this tab, and now I'm going to import not the whole model of the Stat, but just the results. That means we are going to update the structure here with the results of a so-called analysis. The results file is located here, and here opens the dialog of the importing analysis results, and here we don't need to update all of the sections, just the one we have changed. The preview was generated also, and as you can see, the columns are being updated. Okay, next step would be to detail the structure. I'm going to show you a bit of trimming function. Here is the possibility to trim several beams at once. For example, I select them by a priority order. Later on, the priority order can be changed. Now I'm going to trim this one beam to the column by its normal, and this one bracing here I'm going to trim to column by the master profile, by profile of the column, and by the plane of this upper bracing here. This creates a parametric connection. That means if later, after analysis or after some other changes, these profiles are going would be changed, the cuttings will be applied accordingly. Okay, so next we can add some end plates, just simply showing this. There are various possibilities to edit this end plate through entering some values for the extensions, or just by dragging these arrows here. The end plate also creates the parametric connection, and the end plate will adjust to the size of the column if this column is going to be changed. Also, BuiltWorks provides some standard library of the connections, just a simple basic connections which might be useful for the user. All the connections can be created using BuiltWorks features, and later they can be stored into the library or copied to another place of the structure. Okay, next I'm going to show you the export to another format, to SDNF format, and we are going to import the structure to some third-party CAD application. Here, for the export to SDNF, we can choose to export to SDNF version 2 or SDNF version 3. Depends on the third-party application. And there are also the possibility to export weldments, SolidWorks gussets, SolidWorks end caps, or BuiltWorks free plates, or BuiltWorks end plates, also SolidWorks extrudes and other bodies. We're going to export all geometries. And OK. System allows me to open the exported SDNF file for the review. But I'm going to open the structural modeler of the Bentley. And import that exported SDNF file. Okay, so here for SDNF import, I need to select the exported SDNF, and the structure is being imported. Some of the profiles are not quite correctly mapped, so it needs some addition, but after all, the structure is being imported correctly with all end plates. Also, this is not only the geometry, but also some parameters we exported, such as profile names, and the end plates are also editable.
So it's fully intelligent and editable model on which you can go further with detailing and bring the model to fabrication later.
Okay, this is model I'm finished. Now I'm going to show you another model which was created using only SolidWorks features, such as weldments and extrudes. and we are going to export that model also to another format called CS2. Okay, now I can close this. Let me locate that model. Here it is. Okay, and here, as you can see, all the features are from SolidWorks: extrudes, patterns, structural members, weldments, trims, extends. Okay. Now for the export to CS2, I simply open the CS2 export to CS2 feature, and here I can export to CS2 analysis model or to CS2 design model. The analysis model will consist only of the structural members such as beams and other bracings without any plates or any kind of extrudes. Design model will consist of full model and including all the end plates, all the members, all the other some kind of bodies. Okay, here we have the structure of weldments, no end plates of BuiltWorks, no free plates of BuiltWorks, maybe some gussets, some end caps, extrudes, and other bodies. We are going to export all geometry, and here I need to choose the default CS2 mapping file, and simply after I click OK, the structure is being exported. The system offers me to open for the review that exported CS2. Okay, now we can continue with importing that CS2 to some third-party application which supports that CS2, or what I'm going to show you, that we can import the IFC gained from translating CS2 to parametric IFC format, and later on we will upload that IFC file to the Tekla Beam site. For the translation CS2 to IFC, we are using the application called StillWiz. Here I need to locate my exported CS2 STP file. On the browsers I can choose the viewer for the exported, because this software also translates CS2 not only to the IFC but also to VRML, which is the open format for review purposes.
By the way, this is a free application from National Institute of Standards and Technology, and it's used for reviewing IFC CS2 files, the content of them, the specification, as well as the physical model, how it looks like, what members are inside that model before transferring it to another application. It's used for checking the CS2 files, but in this case we will use this to create IFC file, which is possible to export directly from SolidWorks, but Ludas will show the difference how IFC exported as just dump geometry, and if IFC is created from intelligent CS2 format.
Also, what the translation done from that CS2 file is that it created a report of all the sections and the quantities and other useful information. such as total weight of the structure as well. And here, as you saw, this viewer displays the structure, the VRML format file of that structure. Okay. Now here is the generated IFC from that CS2 file. I'm going to create a new project inside Tekla Beam site. Sorry, not a new project, but I will open the translated IFC. Here it is. This IFC also can be imported into Tekla as the reference file. And later on it can be converted to Tekla members easily with all the parametric information. Talking about parametric information, if I click on the beam, here you can see that the profile name was exported and other useful information also. The same with the plates. The size of the plate is here. If we will compare to the IFC gained directly from SolidWorks, here it is the same model, not as colorful as the one before, and without any useful information, just the name of the features from SolidWorks. Well,
so to say, it was just more or less dumb geometry.
Yep. Well, so I'm finished with everything I wanted to show.
Great. So we are exactly fitting into the time allocated for this webinar.
Yes.
And we showed two different workflows. One full integrated workflow, making SolidWorks a data-centric solution with modeling capabilities inside SolidWorks and exchanging data with StatPro. And there was additional question in the list if we can export a SolidWorks model to StatPro, and the answer is yes. Simply in our demo today, we tried to show several formats at once, one for import, another for export, third for linking to analysis and design. But the general message, general idea is that all these interoperability features of BuiltWorks supports equally SolidWorks weldments or SolidWorks structural members, as well as a new feature BuiltWorks member, which is tend to be more intelligent and more flexible for structural steel modeling inside SolidWorks. So you can use really your existing SolidWorks files for linking them now directly to StatPro for analysis and updating the analysis results back to the model. Just for StatPro, we transferred only beams, only structural members. No plates are transferred for analysis. Well, because mainly in structural design workflow, the analysis of the structure is to be done before actually the detailing. The general arrangement model is being transferred for analysis. But if we need to export the data for some CAD application, high-end detailing and fabrication systems, yes, the plates BuiltWorks plates, structural plates, or any SolidWorks bodies and features can be exported as well.
Okay, well thank you very much Arunas and Ludas for that webcast, and thank you everyone for attending.